Example 6. In a photoelectric experiment, so a graph of the light frequency F is plotted against the maximum kinetic energy of the photoelectron. So we have, based on the graph, for the light frequency of 7.14 times 10 to the power 14 hertz, we have to calculate the threshold wavelength, the maximum speed of the photoelectron. Okay, so for this one, we are going to use this one. Okay, this experiment punya equation lah. So we are going to use the Einstein photoelectric equation, which is this one here. Ataupun yang inilah. Okay. Itu apa tu? Ya, itulah tu. So let's do that. So we know that the Einstein photoelectric equation is HF equal to maximum kinetic energy plus dengan the work function. Okay, and then we also know that if we rearrange it so that F becomes the only the subject, is it that one, the only one here, so H2 pergi sebelah, so K max is gonna be divided by H plus work not over H juga. Okay, so from here kita kasih, what do we call it? Simplify it. Not really simplify lah, tapi actually I'll just call it simplification. Okay, so we know that this is actually just threshold frequency punya equation. So that is gonna be that. Okay, so this one here, the y-intercept, is actually the threshold frequency. Okay, so if we get the threshold frequency, we then can calculate the threshold wavelength. So that is just lambda naught C over F naught. Okay, so the threshold wavelength is 6.21 times 10 negative 7 meter lah. Okay, and then question B, the maximum speed of the photoelectron. Kita guna juga Einstein photoelectric equation, half mv max square plus work function. So from here, kita boleh carilah the maximum velocity. So that is gonna be equal to this one. Okay, so basically this is, I would say, quite straightforward. You just need to use the Einstein photoelectric equation and rearrange untuk the maximum speed lah. Okay, alright. So yeah, that is our final example for this whole chapter.